ability to take in a request and do something with it. Let's take all this stuff. For the time being, and this is how we'll cheat. We will say private void seed world, like some sort of ruleful deity. I'm changing this around so we're actually pointing to our internal objects. We're going to bring in our types that we're missing. Okay. So inside of my constructor, I'm just going to say seed the world. I'm just going to put trees where I want, all that good stuff. All right. So here, we actually want to do world. Oops. Hang on. Going to do the first room we find. So we're pointing out a dictionary so we can get the value out. Okay, so we're going to hide the seeding, right? Just our kind of our test Mach-E data. We're going to hide that into a kind of a cheater method right now. We just want to showcase that we have a hive mind, which is our invoker for all of our commands. It's also kind of our game engine. And in that we have a world. And we want to query that world for the first room. And then we want to say, hey, in that room, I'm looking for a player named Gary. And then I can do whatever I want to Gary. I don't really need that so much. Okay, so now that I can get to Gary, I want to do something with Gary. I want to request that Gary does something to something else. So let's get two things. Let's also get Beth. So now I've got Gary and I've got Beth. And I think Beth or Gary, they're going to do something to each other. Nothing explicit or dirty, but we want them to either heal each other, we want one to attack the other, something, right? And we want the game engine to figure that out for us. We don't want to have, like down here where we were saying, var damage equals Gary.fight, and then Gary takes damage and do all the things explicitly. What we'd like to be able to do in some way is just to say hivemind.execute new game request, and then pass it in what we want to do. So we'd pass in the game action is equal to heal, and the sender is Gary, and the target, sender is equal to Gary, and the target is equal to Beth. So that's our command pattern, right? And so if we had a command parser, something on the command line that said, I know who you are, and that would be Gary. And Gary says, I'm in the same room as Beth, and I want to heal her. Well, that would come into the game like this. Oops, hang on. Does not like Beth. What is Beth? Let's go back into our hive mind. Yeah, I made Beth a player. Oh, hang on, let's go into our request. Yes. Ah, okay, little bug. So if you're not familiar with LINQ, LINQ allows us to use a bunch of operators to quickly query objects and collections of objects. So here, where I said where from LINQ returns back an IEnumerable. So target is just one. It's just one game object. And I've returned back this query. It's not even a finalized query. So what I want to do here instead is to say first. So that's going to tell LINQ, it says, hey, go rummage through game objects and return back the first game object with the name of Beth. We happen to know that that's going to be a player, but because every game object can execute a command now, it could be anything. We don't really care. We really don't care. In the future, we're going to want to use like an identifier, maybe a GUID for our needs, so that there's not name collisions. Presumably, there wouldn't be two players named Beth in a game. We do some name checks for that, but there could be a monster named Gary, or a monster named Beth, or a non-player character with that same name. So, especially if we're using like a monster generator, where we're just saying, hey, mash up some names from these lists and throw them out there. So, we've implemented the very, very basic command pattern that takes in a request and passes it along. And we defined our request as being a game action, a sender, and a target. So let's go ahead and review that inside of HiveMind real fast. Ignore the seed world. I'll collapse that. That's just stuff for us to play with. Now execute has no logic. And this is where we're gonna do an algorithm here to do the tit for tat and the back and forth. But for right now, we just kind of want to demonstrate. So it will be as simple as saying var target is equal to request dot target, and then target dot execute request. So this is kind of what we want. It's not perfect, and there's some pretty glaring holes in the logic, but it's just showcasing the very, very basic pattern. And when it comes to Refactor Saturday, we're really going to dig in and do this. We're going to say, how do we get, what kind of game request and what kind of game response do we have to make where we can ask a target to execute an action, and we're just going to get a message back, right? But we're also going to get a bunch of other stuff. So let's just show it. Let's just show it, because we're all right. So we've unpacked the target, and we said, hey target, you need to execute this request. right now the only thing inside of the response object is a message. So if we go into player, oops, where do we want to put that? So we've got this as an override in our base actor. We need to decide if we really want all base actors to implement this. We'll make it virtual for right now. Oops. Hang on. That's a good point. Alright, let's leave that because we're running out of time. But I want to try this out. So this is a test repair message. Nah, too much noise. Let's say repair. Fight. And we'll make it a little bit different. So string.format 0. Negotiates. Let's do that. Let's follow that pattern. Not pattern, but format. String.format. Fights. And we're going to say this dot name. This dot name. And if all this works on the first swing, it's going to be really neat. Because it should open up the door for where we can go with this. So we've done a lot of work over the last 3 weeks, and it'll be really cool to see us actually being able to use it. Okay. So, and again, we want to make our game response more robust because we want to be able to have a deeper and more rich exchange between a target and a sender, and then be able to broadcast the result of that exchange to the world at large. But for right now, we don't want to stray too far from the design pattern we did yesterday, or add too much complexity. So, we talked briefly yesterday about this concept of rendering. So it wouldn't necessarily be the job of the execute command to re-render the room, but we want to bake into our game engine a little bit later on the ability to say, you're in a room, you requested an action, once that action executes, let's redraw the room and append your action to the end. Or if it's a console game and text-based, let's just append the result to the end of your room. But we have to keep our eye out for things that could trigger a re-render or that might come in as a race condition before or after your request. So this seems like a very simple abstraction, this hive mind, but so did this at one point in time. If you go back to the previous videos, like in the first week, and you look at the code, there was really nothing here. But then since then, we've added all these layers of complexity, all these encapsulations of properties and entities, and a lot of algorithms and behaviors and strategies and calculations and overrides and just a lot, right? in the last 3 weeks. So you can expect that same level of complexity in the hive mind.